Hey everyone, thank you for joining us today. My name is Ilias Farfouris and I'm part of the strategic business team at Alcor. Evolve, Alcor's very own digital series, is in motion with exciting topics. It gives me immense pleasure to be part of this series among this global audience and our Alcor family. With open arms and much warmth, I take this opportunity to welcome you all to another session on digital transformation with a focus on analytics. I couldn't have asked for anything better to light up the lamps of this event, designed to share knowledge, and to host today our guest, Dr. Vasileios Papapostolou, a global thought leader and a voracious thinker. With an exemplary journey of many years, Vasileios is the program supervisor for the AQ-SPEC of Science and Technology Advancement at the South Coast Air Quality Management District. An alumnus of Harvard University with a doctorate in science, he started off in the environmental health sector and built an illustrious program combining analytics, cloud, databases, and IoT sensors focused to constantly drive value, productivity, and experience for our Southern California communities, along with global visibility of the program innovations. Before we start the session, I would just like to inform you that post the conversation with Vasileios, we will take up a quick Q&A for the audience. So in case that you have anything to ask, please free to drop it in the Q&A section and we'll pick it up. So Vasileios, great to have you here. Over to you. We're excited to hear about the program and the innovations that you're about to share.
Thank you very much, Ilias, and thank you very much to Alcor for having me today. It's a pleasure to be here, and I'm happy to share some of our experience working with data management and the community outreach aspect of the work that we do at South Coast AQMD. Again, I'm Vasileios Papapostolou. I'm the program supervisor of the Air Quality Sensor Performance Evaluation Center at the South Coast Air Quality Management District, which is located in Diamond Bar in California. So I would like to take a couple of minutes to provide you with a background on our agency and also our program at the agency. So the South Coast AQMD is a regulatory government agency in Southern California, providing oversight to stationary source emissions and covering an area of about 17 million people residing in 4 counties and covering 3 air basins. So we are, the areas in our jurisdiction include Los Angeles County, San Bernardino, Orange, and Riverside counties. And a couple of things about the air quality in the region. Currently, it does not meet the federal PM2.5 ozone and PM10 standards, as those are regulated by EPA, part of the National Ambient Air Quality Standards. The region has the highest ozone levels in the US, and we have over 150 exceedances of federal air quality standards each year. So today's talk will be a lot about air quality because that's the work that we do at South Coast and how that air quality information is producing huge amounts of data and how we are taking steps to manage all those data with the modern tools that we're having these days. A couple of things about the program that I oversee at South Coast. It's called again AQ-SPEC. It was established back in 2014. It's now our 8th year in existence. And the program was established with a main goal to provide clarity and minimize confusion on the use of the sensor technology. It's a new technology, miniaturizing, scaling down traditional monitoring equipment for measuring air quality, air pollutants, as those again are regulated by the US EPA. So the program evaluates the performance of widely commercially available air quality sensors and publish the results on a dedicated public website for the general public to review, read, and make informed decisions when purchasing a sensor device to measure air quality at the neighborhood level. Everything is found on this web link that I've included here on the slide at the bottom, www.aqmd.gov/AQ-SPEC. So data management. So what was the problem that we had at South Coast a couple of years ago? It started off as a problem around sensor data management as part of the AQ-SPEC activities. So at the local level, as we see here, we had a program that involved 9 sensors deployed at a facility, producing lots of data 24/7 on a continuous type of fashion. Then we included a project where we had to deploy 400 sensors at the community level to address air quality concerns at the neighborhood level with community residents involved in the process. Moving on, we included other programs, other projects and activities that required additional deployment of sensors, multiple sensors to the thousands levels. We have a state level program, the California Assembly Bill 617, that involves community air monitoring at the neighborhood level. We have programs that we are supporting at the federal level, supporting the efforts by EPA to develop wildfire response types of activities by having a fire map, displaying data from sensors capturing wildfire smoke emissions, and as those are translated into particulate matter and other hazardous pollutants that are generated from the wildfires, especially in the state of California during the late summer, early fall season. I've included this map here for you to have an idea on the number of sensors that are deployed in the areas of our jurisdiction, again, in the 4 counties down here in Southern California. And our big problem was that all of these sensor networks have been generating lots of amounts of data. So that has been a huge challenge for the data analysts, the data scientists in our organization on how to manage the data, process, analyze, display, map, all that kind of data that we generate. So what were the drivers for the development of our data cloud platform that would host all these types of data? Why did we need the data management platform? So multiple IoT platforms used for various projects with data in different formats, but all of them had limited data analytics and external user experiences. The data analysis workloads are larger than typical tools can handle. We need to store efficiently and have efficient data access. We need to apply quality checks and other quality assurance type of functions to be able to create validated data sets. We also need to apply correction algorithms for sensor performance limitations. And why was a unified analytics platform needed? So silos created with data processing and analysis performed on local machines was a major issue. Also, we face challenges with quickly processing and visualizing results in a web-based format to display on a public-facing website. So a couple of things about the very first steps in the process that we call exploration phase. We had some information, some idea, but we didn't know exactly how we wanted to go about developing the platform to host one or multiple databases that are being used in our organization. So the first thing that we did was to reach out to cloud application vendors in the market. We needed to be able to identify Microsoft or Microsoft preferred vendors because there was already an infrastructure at South Coast AQMD working with Microsoft tools. So we would like to leverage those kinds of tools and make the transition as smooth as possible for everyone in the organization. So we discovered through those discussions and interactions with vendors that most of them were being focused on security aspects. So 60% of the cost being proposed by several vendors out there back in the day, 3-4 years ago, was focused on security. And in addition, there was no prior experience with all of those vendors on air quality, or even worse, with air quality sensors that are becoming very popular, and they generate lots of amounts of data. So what we did was to partner with the South Coast AQMD IT department and their technology team to leverage existing enterprise agreements with Microsoft and also leverage their expertise and deep knowledge on applying security in practice. That's what our organization IT department does day in, day out. And they also had some knowledge on air quality, as that knowledge is translated into those several projects that they have been working on to develop tools and other functions within the organization. So the solution would have to be flexible and scalable to be able to accommodate multiple programs, multiple projects within each program, multiple communities with programs within programs and projects, and also be able to address overlapping community needs and requirements, as those are reflected in the various projects and programs that we have at South Coast AQMD. The end user experience would have to be in a position to remove data storage silos, remove data processing, analysis, and analytics silos, and be able to accommodate enhanced data visualization capabilities, both for internal use and also for public consumption. So a couple of things about the requirements. I've included here phase one, and I will explain in the subsequent slide what that means. So phase one was mainly about the very first step that we took, starting small, with bringing in the sensor database to the cloud platform as the very first step, phase one in the process, to be able to understand how things work, and then from there expand to including and integrating other databases in the agency. So the platform would have to ingest, store, analyze, and visualize sensor data as part of the phase one. So a few things that we needed to do as part of this phase: access IoT devices and integrate to the cloud, access databases and integrate to the cloud, store raw data as those are generated from the sensors, process the raw data into efficient data formats, store process data, and then query data, build analytics, and display on web dashboards, both internal dashboards and external dashboards for the general public. So a couple of things about the work that we did as part of phase one: the sensor data platform added to the cloud. So we developed and built a cloud platform to manage data collected from sensors. We developed and implemented a database storage strategy regarding database type and data format to enable subsequent geospatial time series data analysis. We developed data processing procedures for quality checks and other quality assurance type of work, data time averaging, and air quality index calculations. We built a platform for creating real-time interactive data analytics, both for front-end website viewing for the general public, that is also map-centric to displaying air quality sensor data. And we developed an API and standard data formats to ingest data, and also an API that exposes real-time and historical data collected for a number of different projects at South Coast AQMD. So on this slide, I'm showing a little bit about the architecture with the data flow. So we have the data sources, a number of different data sources that we need to integrate on the cloud. We need to be able to store the raw data generated from all those sources, process the data, store the process data, and then be able to visualize all of these data as they relate to different programs and projects. So as I mentioned briefly, we split up the work into different phases. So phase one was about developing the platform to manage data from air quality sensors, small devices, of low or lower cost that are now miniaturizing big traditional methods of monitoring air quality. Then, when we completed phase 1 in the project, we moved on to phase 2. And the phase 2 included incorporating all of the rest of the databases at South Coast AQMD. And I'll provide some details in the following slide. So phase 2, we split it up based on lessons learned during the phase 1 process. We split it up into 2 phases. So phase 2A was the discovery phase, working with the technology team to identify the requirements and the needs, both for the data flow and the analytics aspects. And phase 2B would be the development or the implementation phase, having gathered all that information during the discovery phase. That approach was very much needed to save significant amount of time. That was part of the lessons learned during phase 1, where we had no prior experience and we didn't know how to very efficiently move with the project. So think of it like discovery phase and development implementation phase during phase 1 were all one type of thing. So there was no different distinct phases in the process. And phase 3, so phase 1, sensor database on the cloud. Phase 2, the rest of the internal South Coast AQMD databases on the cloud. And phase 3 now incorporate external data sources onto the platform, as those are described by traffic count, NOAA data, and other types of information that is not generated by AQMD, but is very much needed for analysis and reporting purposes at the district. And of course, apply machine learning techniques for aggregated data sets and so on and so forth. I've added this slide here to talk a little bit about timelines and deadlines for people to gain some perspective on how things look like in terms of having deadlines on completing phases in the project. So in particular for phase 2, phase 2A, the discovery phase, that was proposed for a 3-month worth of time duration in the process. And it took us almost 12 months to complete that phase. Phase 2B, the development phase, the proposed duration there was 6 months, and the actual duration was double that, up to 12 months worth of time to work on the implementation phase of phase 2B. So as you can see, to design, develop, and implement phase 2, in theory, was going to be up to 9 months, and in actuality, it ended up being almost 2 years worth of work. And this is my last slide here, and it's a very busy slide, but I'm summarizing all of that we just discussed about the development. So you see here on the left side of the slide all of the inputs on our platform. Those are all of the databases, internal databases, all of the programs at the South Coast AQMD, ranging between non-regulatory sensor data to the platform, to regulatory data, laboratory samples, support to programs like the California Assembly Bill 617, refinery emissions monitoring, air quality assessment work, special projects, air toxic studies data, air quality advisories, and so on and so forth. And then also external databases, traffic count, NOAA, NASA, satellite data, all these go into the cloud. And then from there, we have the outputs, which are the internal and external dashboards to be able to communicate properly and accurately the information that we generate on a daily basis. And of course, a solution here for the public, the experts, or anyone who would like to export data. There is this functionality provided with our solution. The cloud platform is able to support tools like HighCharts and RStudio, and it's also compatible with MATLAB, JUMP, Tableau, Power BI, and Excel. So single point of access, 14 databases, and we will be adding more as we speak. And with this, I would like to stop here. And thank you very much for your time. and I'm looking forward to the discussion with Ilias. And if you would like to contact me, please make note of this email address, and I'm happy to follow up with anyone. Thank you.
Wonderful. Vasileios, thank you so much for this context. It will be very helpful for our conversation moving forward, right? A lot of layers, a lot of topics for digital analytics transformation. I think if we go to the last slide, that would be the best slide there to kind of have and share with our audience as we discuss here about the project, the learnings, and how you guys went about getting this project from initiation to completion, right? But let's talk a little bit first about, what does digital analytics transformation mean for today's technology and business leaders, right? Let's talk a little bit about that.
So the key words that come to mind are automation, speed, and efficiency in working with extremely large data sets. So this has been the motivation for us to go into that transformation of our legacy processes that we have at South Coast AQMD for a very long time. All these new technologies added, as I mentioned, the sensor technology is a new technology, and that was the driver for thinking to develop a cloud platform to host large amounts of data from sensors to begin with, and then expand as we saw the need and the usefulness of the solution to other databases, and make this be a district level, an agency level type of solution.
Vasileios, let's talk a little bit about the sensor data, right? We hear a lot about Internet of Things and sensor data, right? In your instance, can you give us a sense, like for the audience, right? What is the level of the data, the size of the data, right? The frequency of the data, so we can become more familiar with this terminology. Absolutely,
Ilias. So think of it like this: a single device. It's a very small device, like at the size of a cell phone. In most cases, there are various types, but an average size is like the size of a cell phone, like a little box. Needs to be operating continuously on a 24/7 basis, and it can go anywhere from measuring one particular pollutant all the way to 5, 6, 8 different air pollutants out there. The time resolution could be as high as 1 minute time averaging. The device may be collecting data every 10 seconds. The averaging can be as high as 1 minute type of time resolution. So we have continuous operation for weeks, months, years, 24/7, 1 to 5, 6, 8 pollutants, and 1 minute time resolution that is an average of 6, 10-second data points. So we are talking about the deployment of a huge number of sensors, as you saw in an earlier slide. We're in the thousands of sensors deployed and that are used for different types of projects at the local, community, regional, state, and federal level within the US and around the world, of course.
That is amazing. We'd love to learn a little bit more as we discuss here, and we'll get into that in the next minutes of our conversation. So as now you are looking at this solution, right? How would you define your journey in taking the first steps towards such a transformation?
It has been a fascinating journey. The people involved in the process have been very excited to be able to develop something that is the next generation type of data management, moving away from manual processes or very slow processes to fully automated processes and very fast and efficient types of processes. So Fascinating journey with lots of challenges though, throughout the entire process from day one till the point now where we are ready to fully implement the solution. Exciting process, but still very challenging.
Okay. Let's talk a little bit about that, right? You, as a technical leader in your organization, you are looking to bring change, modernize legacy processes, right? So let's expand a little bit on some of those key steps, right? And what were some of those lessons learned? Like as you guys started meeting internally to initiate the project, what were some of the key steps in your decision making?
Right. So as I mentioned earlier, we had this huge problem, right, with sensor data management, huge data. So we had tools available to us like, Microsoft Office, other types of tools, but it was all kind of scattered. It was scattered tools, some people being familiar with one type of tool, other people within the organization familiar with another type of tool. When we were looking to integrate our work, there was some incompatibilities as to what kind of tool was used to process one database, one data set. So Excel was used for one data set by that person. Our studio was used from another person to process another data set. Or the same data set was processed and analyzed using two different tools by two different people. So we had this kind of very diverse type of situation going on with how data was processed, analyzed, and overall managed, right? So one of the things that we wanted to do is to harmonize all of these processes. So how would we do that? As I said, we sought proposals out there, but we figured early on that there was no air quality expertise with those cloud application vendors back in the day. I'm not talking about today, but I'm talking about 3-4 years ago when we started conceiving the idea and starting to designing the approach. And furthermore, there was no expertise with air quality sensor data management. So we felt like we were in a position to bring in that kind of expertise, the air quality and the air quality sensor type of expertise, and partner with a group that can easily address security issues, data management from a different type of perspective on the cloud type of environment. And that's how we partnered with our technology team at AQMD, that is mostly the IT people, to marry these two fields, if you will, right? The air quality experts and the actual technology team on the new tools that are becoming available, the platform, security aspects, enhanced security aspects, and so on and so forth. So that was the initial step. That's how the team was formed, sorry. And we started taking very, very small steps in the process. As I said, the sensor database was the first database that we used to build the backend infrastructure and start small with managing that data and then expand slowly to the other data sources.
So I'm sure that working with sensors brings some challenges, right? So, having now the cloud innovation, how are you able to bring some of this sensor data into the cloud, right? Talk to us about that journey, how you collaborated with your technology team to enable that and bring that data into your core platform.
Yeah, this is an excellent question, Ilias. It has direct implications on cost. Okay, so the actual technical part of it, you have the vendors out there, sensor vendors own their devices, and they can accommodate ingestion of the data onto a different platform, for example. So that's taken for granted, let's say. So at the time, we were working with two different vendors. So we had APIs developed to push or pull the data onto the platform. And then from there, we realized early on that there was an associated costs with that type of process. So what happens is, do you develop API to query data, or do you send the data directly to the platform? So we figured in our case that going with the API type of approach may be a cheaper approach, a cheaper solution, as to compare to directly sending the data to the platform from the source.
Excellent. Excellent. Thank you for that context. In the answers now, I'm very interested to learn here. I think our audience will be interested to learn the same, right? We're talking about utilizing cloud and broader digital transformation to modernize legacy processes, right? So in that, there have been multiple teams involved, and there are multiple lessons learned. Could you expand a little bit on that side of how you brought your different teams together to discuss the architecture of the platform and then the enablement, right? And as you serve in the public also, how you brought that into the mix?
Yes, great. So as we said, we started very small, phase 1, sensor database. So the small team back then gained a lot of experience working on the phase 1 of the project. Sensor database on the platform, starting with the backend development, developing dashboards for the sensors alone, and all of the other processing and analytics type of work, quality checks, storage, raw data storage, process data storage aspects, costs implications. So at the point where we were ready to go on with phase 2 in the process to bring in all of the rest of the databases that you see here, we were already, that small team was already in a good position to be able to communicate properly capabilities and limitations in that undertaking. So multiple meetings with all of the different groups, ground staff, the actual data analysts and data scientists were involved in the discussion from day one, management that would provide oversight and would bring in perspective that was not necessarily available from the ground staff, because management would be more exposed over time to communities, to the public, address concerns, be involved in processes where there is issues that need to be resolved together with the communities and the public. So ground staff involved, the technical experts, the people on the ground, data analysts, data scientists, and also the oversight by supervisors, managers, to provide the additional perspective needed for this kind of development. So multiple meetings were held. We laid out examples. We presented all of the teams with what we did during phase 1 and how this could be expanded to include all of the rest of the data sources and what kind of powerful tool we were thinking we would be able to develop in collaboration with all of those teams.
Awesome. Awesome. So let's talk a little bit at the program level, right? The program leadership perspective level. And some of the steps that you guys took to prepare, right? You definitely were dealing with bridging a gap there, right? Between an old way of doing things and now transforming the organization into a new way of things, right? So if you were to suggest a few steps for the audience to be aware of, what would those be?
Yes, great. So one thing we did, we started discussing with all of those teams, and it was all verbal conversations, right? During the Zoom meetings these days, right? And they were laying out information about their data, but you would follow up to a certain point, but then you were getting lost in the process because you were not the one owning the data, like knowing in depth what you were dealing with. So it appeared that it was extremely necessary early on to have each and every team involved you see there all of these databases. So each database is a different team consisting anywhere from 5 to 10, 15 people. Okay, we realized early on that we needed to do the following: develop data flow diagrams. We needed to know how the data traveled from the generator, okay, in quotes, the monitoring equipment used, all the way to the landing environment, whether that was a laptop, whether that was a desktop computer, whether that was any type of environment where they would store data and then take the data and process and analyze. So data flow diagrams was an excellent communication tool for us to be able to be on the same page with each and every team that would be added onto the cloud. So that was one. So I think, and I emphasize on this, that data flow diagrams are extremely important in the process. So that's one of the key things that I would strongly recommend. And then, of course, develop examples and leverage experience and knowledge working on other projects. Like in our case, for example, we had been working, my team has been working on a project with deploying multiple sensors and working with 14 communities in the state of California to properly operate, maintain that technology, and then collect, analyze, and interpret the collection data. So in part of this process was also working together with all of those community members. Imagine a group of 400 people, multiple webinars, multiple workshops, in-person workshops, especially before the COVID era, and brainstorming together with all of those people in the public on how we develop tools that are very useful for the non-expert or for people who have some kind of expertise, but they're not necessarily an air quality expert, but they would like to gain air quality information to address their concerns, their personal exposure, their own activities. So in this process, we gathered lots of information, lots of intelligence on how to develop, for example, external dashboards to easily communicate the air quality information. That was very useful, and we brought that into the discussion for the data cloud platform development. So like, for example, when we asked all of those teams, okay, each database may need its own dashboard solution. There will be overlaps. You may have one dashboard combining 2 or 3 data sources, but then there may be a data source that requires each standalone dashboard, because that's the nature of the data. They cannot be combined with other information because it may be extremely confusing. So we put together all of these examples that we had developed for the sensor data platform, and we asked them to review, modify, edit, add, and adapt to what their data was about.
Awesome. Thank you, Vasileios, for this context. It was very helpful, right? I mean, you are dealing with a solution here that needs to serve not only the internal users, but also external users, right? So I'm sure as you are going through this transformation, in some of your discussions, you are discussing, great ways on how to mitigate this risk, right? So for our audience, what strategy would you recommend for minimizing resistance to the adoption of such analytics transformation and introducing this new technology?
This is a great question, Ilias. So yeah, for sure, this is exactly what we do. It's we are a public agency. We're serving the public, and the ultimate goal in our mission is to develop tools that are available to the public, that the public can embrace, can find useful and helpful to read, review air quality information, and also, as you can see here, to be able to provide functionalities such as data export type of functions, where anyone from the non-expert, the community member that just needs simple air quality information, all the way to the API developer to the researcher, to the professor, to an air quality expert working for a scientific consulting firm, for a business, or for another air quality agency to go and download data and do their own processing and analysis of the data. So all these functionalities are what we had been focused on from day one, to be able to properly serve the public and have the public make use of that tool, because after all, it's a tool that it's for them. It's for them. It's for their air quality information. So that has been our mission throughout the process.
That's excellent, right? I'm really keen to learn a little bit more about the public that you serve, right? Because you have different layers of those data users and different skill sets, right? I may be just a community person, and my skill set is not going to be the same as a data scientist or an API developer that needs to have access for that data. So walk us a little bit about the thought process on how to serve that side of your consumer in your instance, your data consumer, if you will. A lot of people can find this very useful.
Very good question too. So this has been a huge challenge. So how do you develop a dashboard that talks to anyone and everyone? Sometimes it's extremely hard just because of the nature of the data. Again, remember, we are an air quality agency, okay? So there is information that can be very simple, but there is also information, there is also analysis that is being performed that is more elaborate, it's more advanced, it's more involved. And it's using tools that are not necessarily available or known to a large number of people out there. So we have different levels of users as we define them. So like, for example, we have 4 levels of users. Level 1 would be just the member of the public, as I said earlier, that goes reviews and is willing to gain some air quality basic information about how to go outside and exercise, for example.
I can be a resident, for example. I live in South Californian community. I just want to check in how the air quality is in my neighborhood, right? Just very simple use case, right?
With color coding or some other type of communication tool that is easily interpretable by the non-expert. Level 2 could be a student, a college student, a high school student, a university student, or a researcher, a community scientist, if you will, a member of the public with some expertise in using tools, data analytics tools, or being able to go in depth as far as air quality information is concerned. Level 3 could be the more involved individual. Again, it could be a researcher, a professor, an air quality expert, those kinds of people who would like to do research, more research with the data. So in this case, they can go and they have the capability of downloading data and do their own analysis on data that is reliable and accurate and of very high quality. Because as we said, we're also in the process of applying QC, quality check rules, developing correction algorithms, and doing all of this kind of work that improves the quality of the data that we generate or we make available for anyone to use for their own research purposes. And then the level 4 type of user would be the API developer or an expert who wants to do modeling work, also a researcher. So we have those kinds of layers that we also mention on some of the dashboards so that we can communicate in a more effective way what kind of audience this kind of dashboard is closer to. Okay, so we don't want the audience to be overwhelmed or to think that, okay, this is extremely basic information. We want them to understand that there is all these different layers, different options, going all the way from the very basic information for X, Y, and Z types of purposes, all the way to a very involved type of information or data availability for other types of work.
This is awesome, right? For our audience here on our session, right? You have a lot of concepts there, right? You have one that is usability by your level 1 user, the community member, right? So UI design perhaps come in mind. You have obviously one that you have, the more scientific now users that can grab this data and use it for other purposes that have more skill set, right? And like in there, you have a lot of architecture concepts as well, right? So let's talk a little bit about how you chose some of those components and put it into your transformational project.
So let's say, are we focusing mostly on the tools used? So this type of approach was developed in close collaboration with all of the internal teams at South Coast. So we had one team working on Python for a long time, you know, generating data from their monitoring equipment, bringing it to Python, doing some analytics work, and then we would go and present that team with the solution, and the team would request, I've been working with Python, I would like to continue working with Python. Will the cloud provide that capability, that function? So we would need to accommodate that kind of need, that kind of request. So we went about including Python. Other teams, many teams have been working with RStudio, very familiar with RStudio, very comfortable working with RStudio. So we work closely with the RStudio team to integrate the RStudio tools onto the cloud platform. That was a process. But at the end of the day, developing a district level, an agency level type of solution, you need to be in a position where you accommodate all of the needs and requirements from all of those different teams. That talks to the success, to part of the success of the solution. And the other part of the success of the solution is for this kind of tool, this kind of solution to be embraced by the public and have it be useful and helpful to them to go in and understand their quality information or analyze their quality information.
That's pretty awesome, Vasileios. Let's talk a little bit about, in detail about, you know, how as a technology leader, do you believe that analytics transformation is fundamentally changing how organizations create value and better experiences for their community?
I can talk about what we do at South Coast. So I would say this is a huge step forward. The adoption of the cloud computing, the cloud platform, and the cloud computing, and that integration of multiple databases and the development of multiple dashboards for public and internal consumption, it's an effort that right now I'm not sure that is being undertaken by other entities in the air quality type of environment. So we're very happy that we're able to have this kind of opportunity to work on this development with lots of support by our executive management internally at South Coast AQMD, lots of support by the technology team, and that will be an amazing type of environment for data analysts, data science to go in and work with any type of data that they could have imagined, and multiple tools that we have here, lots of options, and make this be extremely powerful, very automated, very fast, and very efficient. So, like, for example, we need to generate a report. You need to generate, to develop some analysis, okay, to inform the public, to report to your management. Those processes will be fascinating processes, I believe, from now on. Moving from being too elaborate and too cumbersome or slow to now something that you will be enjoying working with. Like, for example, there is one of those data sources that is equipment on mobile platforms. So you have a vehicle, a van, we have a vehicle, a van, or multiple of those outfitted with monitoring equipment, regulatory grade, research grade, commercial, consumer grade equipment. So imagine like 10 different types of equipment on a platform. And those so far have been generating data that would be transferred onto an equipment vendor provided laptop that would also carry the vendor software compatible with a piece of equipment that was being used. So that would be an automated process right there. But from that point onwards, the data analyst would have to manually take that data from the vehicle on a thumb drive and bring that data back to the office and process, analyze, generate plots, reports, and other types of analysis. That will now be eliminated. So we're moving from that kind of manual, extremely cumbersome, highly risky, security-wise process, and very, very slow process to something fully automated, very secure, and very fast type of process with lots of additional capabilities, and that is all on the cloud. I hope this example provides some perspective here.
Yeah, it does resonate, right? Because I mean, you are definitely combining a lot in analytics, not just only simple analytics transformation, right? Let's do things more efficient just for reporting, but bringing in cloud technologies, and on top of that, working with challenging data sets from sensors, right? And Internet of Things devices, right? Which in there you have the huge amount of data that you're dealing with, that you need to have ready and accurate to be processed for your data consumers, your internal data consumers or your external data consumers. So let's talk a little bit about how do you measure the success of your analytics transformation initiatives, right? What are some of the processes and measurements you have taken in to see how that drives value?
Yeah, I touched on it a little bit already, but again, we think of the success of this work. It's a dual type of situation, right? So success is translated into internal staff, all those teams involved in the process, embracing the solution, enjoying working with the solution, expanding on the capabilities, and having an environment, a data environment that they feel it's very secure, of very high quality, and very efficient and effective in performing their work and developing reports and other types of analysis. The second part of the success is how the community, again, embraces the tool that is for public consumption to a great extent, and finds all of the work useful and helpful for them to address air quality information and their concerns about the air that they breathe. So both internally and externally, the success is as I described it, I think.
That's pretty awesome, Vasileios. Thank you. So, just to close our conversation, we talked about you being a leader in the space and being one of the innovators to have such an analytics program, right? But for others that want to get into an analytics journey, right? An analytics journey, analytics adaptation journey. What advice would you give them to start and to be able to, at the end, drive value and to provide a better experience to their teams internally and to the communities or consumers that they serve?
Yeah, great question. Start small. Start very small if you can. Like in our case, we could start very small and explore and experiment. So we started very small with a huge database. We started very small with a sensor database, still lots of data. But as you see here, after all this time that we've been talking, we started really small, right? Because the ultimate goal was to also add another 12, 13 databases onto the cloud. So start very small, look who's next to you, look how you can leverage expertise within your organization, how people can contribute to designing, developing such a solution, and then very carefully lay out, address the needs that you may have, and you go out and you seek help in the sense of partnering, collaborating with external entities, hiring people, hiring entities to fill in any gap that you may have within your organization to develop such a solution. So start very small, work internally with your teams, adjacent teams, other experts within your organization, and then start seeking assistance from the outside to fill in the gaps.
Wonderful, wonderful. Like a lot of learnings today. Vasileios, thank you so much for your time. Thank you for going into details of this amazing analytics transformation. It was a pleasure having you here. And we look forward to having you again and being in contact.
Thank you very much, Ilias, and thank you to Alcor for having me today. I hope you found this information useful. And again, I'm available to talk with anyone who would have more questions or ideas. Here's my email. Feel free to shoot me an email whenever you want. And thank you very much again.
Thank you. We appreciate you stopping by. See you soon. Take care.
Bye-bye.